You know, in the world of AI, every now and then a paper comes along that doesn't just tweak a model a little bit, it completely changes the blueprint for how we build them. Today, we're digging into one of those papers, HuggingGPT. It introduced this radical new way of thinking about AI agents, not as some single all-knowing brain, but as something way more powerful. Think of it as the conductor of an entire AI orchestra.
So before this paper, large language models, or LLMs, were kind of like these virtuoso solo musicians. I mean, they were brilliant, capable of incredible feats with language, but they were fundamentally alone. They were limited to their one instrument, text. The HuggingGPT paper basically asked, what if the LLM wasn't the soloist, but the conductor? An agent system that could manage a whole team of specialists, an entire orchestra of expert models.
And that is the million-dollar question, isn't it? It's one thing to be a world-class violinist, but it's a totally different skill to get the strings, the brass, the percussion, all playing a symphony together. How do you get a model that only understands text to manage vision models, speech models, and who knows what else, all working in perfect harmony? That's the huge problem HuggingGPT set out to solve.
All right, so here's what we're going to cover in this explainer. We'll kick things off with what I'm calling AI's virtuoso problem. Basically, the limitations that made this research so necessary. Then we'll meet our AI conductor, HuggingGPT. We'll walk through its four-step process, see what it means for developers, and finally, we'll look ahead to the future of AI agents.
Okay, let's start by setting the stage. To really get why HuggingGPT was such a lightning strike moment, you have to understand the world it was born into. LLMs were absolutely taking off, but they were already hitting some pretty serious walls.
Yeah, the challenge really boils down to three core limits. First, LLMs were text in, text out. Simple as that. They couldn't see a picture or hear an audio file. Second, they were single-minded. If you had a complex task, like say, describe this photo and write a poem about it, that was a no-go. It needed different models, and there was no way to coordinate them. And finally, you had the generalist versus specialist problem. LLMs were good at a lot of things, but they often got smoked by a specialized model that was fine-tuned for one specific job.
And this brings us to the core genius of the paper. If the whole problem is getting different expert models to talk to each other, what's the one thing the LLM is an absolute master of? Language. The researchers have this brilliant idea. Let's use language itself as the universal interface, the sheet music that the entire orchestra can read from.
So, what is HuggingGPT exactly? Well, the paper defines it as an LLM-powered agent that acts as a controller, basically the brain of the operation. It plugs into the massive library of models on Hugging Face and uses what it's best at, language, to plan out tasks, pick the right model for each job, and then pull all the results together at the end. The really crucial thing to get here is that the LLM isn't doing all the heavy lifting itself. It's delegating. It's the manager.
Now, that all sounds fantastic in theory, right? But how does it actually work under the hood? Well, the paper breaks it all down into a really clear, elegant four-step process. This is how the conductor actually leads the orchestra.
So first up, task planning. The LLM puts on its project manager hat. It looks at your request and breaks it down into a logical to-do list. Step 2, model selection. For every single item on that list, it scans the descriptions of thousands of models on Hugging Face and picks the perfect specialist for that specific job. Third, task execution. The system makes the calls to those chosen models and they go off and do their thing. And finally, step 4, response generation. The LLM gathers up all the different outputs and weaves them together into one single coherent answer for you.
Let's make this real with an actual example from the paper. So a user uploads this image and asks a question that sounds simple, but for an AI, it's actually pretty tricky. Can you describe this picture and count how many objects are in it? See, this needs both computer vision and logical reasoning.
And boom, right there you see step 1 in action. The LLM gets the request and it doesn't just try to answer, it thinks. It formulates a plan. It knows it can't do this all at once, so it breaks it down. First, I need to get the gist of the image, so I'll generate a caption. Second, I need to find the specific things, so I'll run object detection. And third, I'll count up what I found. It's just a perfect logical breakdown of the problem.
Okay, the plan's in place. Now the conductor has to pick its players. For task 1, captioning the image, it searches Hugging Face and finds a specialized image captioning model. For task 2, finding the objects, it picks a powerful object detection model. It's literally matching the task to the expert by reading their resumes, their model descriptions.
And then we get to the final steps, execution and response. The captioning model runs and generates the text, a herd of giraffes and zebras grazing in a field. The detection model runs and identifies 5 distinct animals, drawing boxes around them.
The LLM takes these two very different pieces of information from two expert models and synthesizes it all into the final answer. And just like that, the symphony comes together.
Okay, so we've seen the how, but now for the big question. Why did this matter so much? Why was this architecture such a total game changer for developers and really for the entire field of AI? What did this new blueprint actually unlock?
You have to remember, at the time this paper came out, other agent systems like AutoGPT were just starting to make waves. But as the paper points out, HuggingGPT was playing a totally different game. AutoGPT was focused more on general daily tasks, using step-by-step planning and tools like web search. HuggingGPT was built for specialized AI tasks. It created the full plan up front, what the paper calls global planning, and its tools weren't just a search bar. Its tools were other expert AI models.
When you put it all together, what this new way of thinking unlocks is, well, it's huge. It gives developers a scalable blueprint for building AI that can handle vision, speech, whatever you throw at it. And the best part? It gets more powerful over time. To give the system a new skill, you don't have to spend a fortune retraining some gigantic model. You just need a developer somewhere to add a new specialist model to the Hugging Face community. The orchestra just keeps getting bigger and better.
Now, of course, no system is perfect, and the paper was refreshingly honest about the challenges that were still on the table. And looking at those hurdles really helps us understand the path forward towards more powerful, more general intelligence.
The researchers were really upfront about the hurdles. They pointed out 4 big ones. First, the whole system is only as smart as its conductor. The LLM's reasoning ability is the main bottleneck. Second, all these back-and-forth calls between models can be slow and inefficient. Third, there's the token limit. You know, the context window. You can only stuff so many model descriptions in there before the LLM runs out of short-term memory. And finally, LLMs can be a bit unstable. They don't always follow the plan perfectly.
But here's the cool part. Those limitations, they actually point us toward an incredibly exciting future. It forces us to ask this really powerful question. What happens when the conductor, that core LLM, gets smarter, faster, and has a way bigger memory? And at the same time, the orchestra of available specialist models grows exponentially.
So let's just imagine for a second a future application built on this idea. Let's call it the automated creative director. A user types in a simple brief, create a 30-second commercial for a new coffee brand, make it feel cozy. The agent, our conductor, plans it all out. It calls a script writing model for the copy, an image model for the visuals, a voice synthesis model for the narration, and a video editing model to stitch it all together. And out pops a complete, ready-to-go commercial. That's the kind of complex creative task this architecture points us towards.
And that really brings us to the paper's powerful conclusion. The authors knew they were onto something huge. They weren't just building a clever system, they believed they were, and I quote, paving a new pathway towards achieving artificial general intelligence. By showing how a reasoning engine could coordinate a world of expert tools, they laid down a fundamental piece of the AGI puzzle for the entire field to build on. And that core idea of a conductor leading an orchestra of experts is an idea that continues to shape the entire field of AI agents today. Thanks for joining this explainer. This is for entertainment purposes only.